Hello, my name is Roni Matin and I am a student at SBMI in the University of Texas. For this presentation, I would like to talk to you about EHRs and usability. The push by the High-Tech Act to encourage healthcare providers to use EHRs has led to their implementation in the majority of hospitals and ambulatory care facilities. EHRs have brought significant benefits to patient quality of care by presenting the clinician with a comprehensive view of a patient's health information and history during the encounter. The more sophisticated and larger systems are integrated with other hospital systems, such as labs and radiography systems, to provide decision support at the point of care and can provide direct automated medication ordering, often via order sets. But there have been some unintended consequences of health information technology, with high incidences of medical error and increased workload for the clinician. Systems are described as difficult or cumbersome to use, often resulting in poor user adoption. And during my experience implementing systems, I have witnessed the difference in response from user groups when demoed systems that looked difficult to use from those that had more appealing user interfaces. A system that is not used cannot be deemed a success, so I wanted to understand usability. Studies, such as by Clark et al. In 2014, have shown that training or experience with an EHR does not necessarily contribute to its acceptance and adoption, indicating that other factors may be involved. There is a great body of work indicating that the usability of a system plays a significant role in the user's acceptance, satisfaction, and ultimate adoption of that system. So what is usability? Usability, as defined by Zhang et al., is how useful, usable, and satisfying a system is for the intended user to accomplish goals in the work domain. This diagram from work done by Sarayon et al. In 2011 indicates that along with the functionalities of an EHR system, its usability is the other main thing that affects its acceptance. So how is usability evaluated? There are a number of methods that are focused on the user's experience of the EHR, and data from users has been collected using questionnaires such as the Questionnaire for User Interaction Satisfaction, or QS, as well as other questionnaires, which include Likert scales to weight responses. Also, there are surveys, which can be online and accessed via links, or there are email messages from clinicians that enable them to provide their responses in their own time. And lastly, interviews directly with clinicians are often used and can include a mixture of closed-ended and some open-ended questions to allow clinicians to use their own words. Usability testing measurements often involve task analysis, and the approaches commonly used are key-stroke-level modeling, or KLM, where the time taken to perform a task by the user is measured. The time is calculated for the steps involved in each subtask as part of the main task. Another method, often used in conjunction, is video-based testing, where data is collected by recording the subject as they use the think aloud technique, where the user verbalizes their thoughts and actions as they perform the task in the EHR. Moray software is used to record the user's actions within the system. While usability testing records the user's actions, usability inspection involves expert evaluation of the system. An example is heuristic evaluation, which according to Kushnaruk et al. Involves usability specialists judging the user interface and system functionality against established principles of usability and good design. Basically, this involves estimating the usability of a system by interface design experts who systematically examine the interface and functionality against a set of heuristics or rules of thumb, such as guidelines, standards, and for consistency. Another method is the cognitive walkthrough, where cognitive psychology principles are applied to simulate the cognitive process and user actions when performing a task. This is often used in conjunction with Nielsen-Scoms model for goals, operators, methods, and selection rules. So which method is the best? Well, while questionnaires are structured, they force the user to stick to categories devised by the researcher and are retrospective. Interviews can provide richer feedback, but sometimes can be unstructured, requiring a lot of evaluation and processing. Task analysis and testing are very good at capturing errors, but afford little opportunity for the user to express their experience. So it appears that different methods work better for the specific situation or aspect of the EHR being studied. And work from Walji et al. And Horsky et al. Indicate that using a combination of methods work better than any single method alone when studying usability. So we come to the TURF model developed by Zhang and Walji. The TURF model provides a framework for studying, evaluating, and designing EHRs with good usability. TURF, which incorporates tasks, users, representation, which is how information is presented, and functions, provides a set of measures for the useful, usable, and satisfying dimensions of usability mentioned at the beginning of this presentation. Human factors. To improve usability, the user interface should be designed and developed with the user in mind. The TURF framework outlines a number of user-centric interface design principles important for usability in human-computer interactions, or HCI. For example, these are consistency and standards for the layout, fonts, language, and terms used, minimalist design in the form of uncluttered screens with meaningful color schemes, and helpful error messages, as well as allowing the user to undo mistakes. All make for systems that are easier to use and less frustrating. These principles can be applied to a more prototyping, iterative approach for system design and implementation. And studies indicate that workflow analysis should be incorporated in system design, as well as involving users in the decision-making and design of the system. So how do we involve the user in the design? One possible option is the usability lab. Simulation centers have long been present in many large teaching hospitals, and they are used to train clinicians as well as for the testing of medical devices. One approach by Landman et al. Used the existing infrastructure and hardware of a hospital simulation lab and installed EHR software to create a usability lab. Clinicians then played out simulated clinical scenarios using the EHR system, while researchers made observations and recordings. They even included actors to cause interruptions, as you might find in real patient-facing scenarios. In this slide, you can see some of the pictures from this usability lab created by the Landman group. Usability labs provide many benefits, such as a near-real clinical setting with no impact on patient services or the staff working there. The availability of an in-house usability lab means you can get testing results faster than you might from a vendor during prototyping. Also, it is possible to devise complex clinical scenarios for testing unexpected or atypical things in the EHR by building in interruptions and additional problems that are closer to real-life events compared to the potted scenarios that are often part of standard system testing. There are many considerations for setting up a usability lab, such as coordinating with the IT department to ensure that the EHR software being tested is the same version as the production system, but can be run with dummy data so as not to impact the live environment. Also, the physical environment must allow enough space to set up observation areas, and there should be enough workstations on wheels, or WOWs, with the EHR system installed close at hand when needed. As setting up a usability lab is very costly, consideration should be given to whether a dedicated facility is necessary, or the more economical option of a shared unit by converting a simulation lab might suffice. Ultimately, usability labs provide an ideal approach to engaging clinicians and other users in the user-centric design and implementation of EHRs. In summary then, while EHRs are commonplace, user adoption is still slow. Improving the usability of EHRs may help to address this problem. While there are many methods for evaluating usability, the TURF model provides a good framework for the user-centric design of EHRs. And usability labs may be the way forward for the study of healthcare systems, as well as the user-centered design and development of the EHRs of the future. Thank you for listening to this presentation. I can be contacted at roni.matin@uth.tmc.edu for the references used in this presentation. I leave you with this picture of a simulation in the usability lab here at UTH.